Okay, so mock visible to everyone. So have you all attempted the mock?
Which one you're saying?
The end mock that we have released. See, the one I'm presenting right now.
we don't have access to the portal.
You don't have access to the mock?
The portal which you're showing, right?
Yeah, this one is the Python portal, right, for
Yeah,
this term.
yeah. We don't have access.
You don't have access. Why?
Not me, everybody.
Okay, why is that?
I don't know. Like they didn't give the access.
So you haven't attempted the mock, any of you.
Nothing.
Have you informed about this issue?
Yeah, in the first session itself.
Since when is this going on?
I believe from the start, everybody can pitch in.
So for you, where are you watching the lectures from, or doing the assignments?
We are not doing any assignments, just watching the playlist which shared by the mail.
Ma'am, I believe this portal is
Okay,
for
okay,
them.
okay.
It is for later enrolled in program.
All right. I get it. Okay, this is the separate
We
group
have
of students.
PDF and we will do that one.
So this is
Okay,
for the
okay,
qualifier exam, right?
okay. Yeah. No issue. See, we'll just solve this mock paper. Okay. So this is covering content from all the weeks of this Python course. So there are 20 questions. We are going to go through all of them. That will do a nice revision of all concepts. Okay. So this is the first question. That is graph G. You can see that can be defined as an ordered set. G and V and E are what? V is the set of vertices. E is the set of edges. So where V represents the set of vertices, E represents the set of edges. For example, this graph. So for this graph, you can see what are the vertices 1, 2, 3, 4, like this up to 8. We have 8 vertices and edges. How many edges are there? So you can see that between vertices 1 and 2 there is an edge. So one edge can be represented by 1 comma 2 like this. All of the edges are represented. You can see there are a total of 9 edges in this graph. Right. So in an undirected graph, edge u comma v and v comma u represent the same edge. Right. So if I can go from node 1 to 2, I can also come from node 2 to 1 since it is undirected. Now this graph can be represented as a dictionary where the keys are vertices and the values are the list of adjacent vertices. So everyone is familiar with dictionaries, right?
Yes.
Okay. So what are the keys of this dictionary? You can see these are the distinct vertices of the graph that we just saw, right? So all of the keys are 8 distinct vertices. Now for each key, what is the corresponding value given? The neighboring vertices. Like, see in this vertex 1, what is the neighboring vertex of this? For vertex 1, what is the
2.
neighboring vertex? 2. Right. For 2, what is the neighboring vertex?
6, 3, 8.
1, 3, 6, 8, all 4 of them, right? Because I have
Yeah.
direct edges to all of them. So like this, we have just created a dictionary where the distinct vertices are the keys, and for every vertex, the corresponding value is a list of all neighbors of that particular vertex. So in the code given below, graph is a dictionary of an undirected graph, and vertex is a singular vertex that belongs to this set of vertices of the graph. So assume that graph doesn't have any self loop. That means from vertex 1 there is not a loop coming back to that same vertex 1 only. Right? So there are no self loops involved and no more than one edge between any two vertices like vertex u and v. There should be only a single edge at max between them. Now we have defined some functions. Okay, so you have to understand what these are doing. So let's say the first function, if we see definition of the function is the function name is f. It is taking parameters, the graph itself, that is this dictionary, and a particular vertex, any vertex it can be. And it returns the length of What? So what does this represent? Graph of vertex. So in this dictionary G that we have created, think of this as the graph dictionary. What does, for each key, what does the value represent?
The number of neighboring vertices.
So for a particular vertex, what will length of this value represent? Like if I say for vertex 2, what is the length of the value? How many members are there in the list?
4.
4.
So what does
3.
this 4 represent?
Neighbors.
The number
That
of
means
neighbors.
number of neighbors of a particular vertex. So see, the first question is saying degree of a vertex V is the number of vertices adjacent to it. That is that the vertices that I can reach directly by using an edge. So is the following statement true or false? The function f that takes graph and vertex as its arguments returns the degree of vertex in a graph. So it is true. Degree means number of neighboring vertices, right? Now, second one is saying for the graph given in the common data, what will g of capital G return? So g is this second function. It is taking this graph dictionary as its argument and it is returning length of the dictionary. So what does length of graph mean in this particular example? What is that?
Number of vertices.
Number of keys, right? Distinct keys. How many entries are there in the dictionary?
8.
So 8 entries are there. So length will return 8 only. So that's a numerical type question. Now, see, these are very easy questions, so you get only 1 mark for each of these. Third one is saying, again, true or false question. Age of graph returns the number of edges in a graph. So age is this function. What is it returning? It is taking that same dictionary as its argument and is returning sum of what? See, inside what is happening in this list comprehension. So f function is being called inside this h function, right? So it is taking the graph dictionary, any particular vertex V, and this function will be called how many times? For as many vertices as there are in the graph, as many distinct vertices as there are. So what does f function return for every vertex?
Neighbors.
Number of neighbors. So if I do a summation of all of them, and then there is a floor division by 2, what does that mean?
Number of
Are there even
edges.
neighbors?
Edges.
First of all, tell
Piece
me,
of edge.
if I just add all of the neighbors, right? If I add all of the neighbors, now can I tell you that if I go to vertex 1, for that the number of in the neighbor list, there is just vertex 2 present, right? In the graph you can see from 1 to 2 there is an edge, 1 doesn't have any other neighbors. But again in the list for vertex 2, 1 is present. So this 1 2 edge is being counted how many times?
2 times.
2
Twice.
times. Once as 2 being a neighbor of 1 and once as 1 being a neighbor of 2. But these are both the same edge. Since it is undirected, that's why it is being calculated twice. So while we find the summation, we are basically doing nothing but adding the number of edges twice, all the edges, right? And if I do a floor division of that, then that will give me what? Floor division by 2 will give me what? See in the H definition, there is a floor division by 2.
Directed edge.
Number of edges. See,
Okay.
let's understand this again. Okay. In the graph, see, look at the dictionary. Okay. So for 1, how many neighbors are there? 1 neighbor, right? For 2, how many neighbors are there? 4 neighbors. So for 3, there are again 4 neighbors. For 4, there are again 2 neighbors. So like this, add all of them. Okay. So for 1, we get 1 neighbor. 2, we get 4 neighbor. 1 plus 4, 5. Then for 3, again 4 neighbors. 5 plus 4, 9. Then plus 2, 11. Plus 1, 12. Plus 4, 16. 17, 18. How many total neighbors have I found? Summation 18. Now if I do 18 floor division 2, I'll get 9. And that is what? The number of distinct edges in the graph. Is it clear
Yes,
why
teacher.
this happened? Because for 1, for when we come to vertex 1, the neighbor is 2. But when you come to vertex 2, again 1 is considered as a neighbor. That means 1 and 2 are being considered twice. This edge 1 to 2. This is being considered twice. So we do a floor division by 2 because this case is same for all of the edges. Like there is an edge from 3 to 6. There is also an edge from 6 to 3. But they are the same edge, right? They are just being calculated twice. So after you find the summation, you do a floor division by 2. And that will give you distinct number of edges. So the answer to this is also true. Now, fourth question is interesting. It is saying that a regular graph. What is a regular graph? Is a graph in which all vertices have the same degree. What is degree?
Number of edges connect to the vertex.
Right. Or I can say number of neighbors a vertex has.
Okay.
So that is the degree. So we are saying that in a regular graph, the criteria is that all the vertices will have the same degree. That means what? All vertices have same number of neighbors. Correct. So we have to complete the function is regular that takes the graph dictionary as parameter and returns true if the graph is regular and false otherwise. Right. So again, see, this is the definition. So def is regular graph, and then you have to fill in that what should be the function definition. So we have given you two snippets of code. So let's analyze. So I have to write a code such that the code will check that whether every vertex has the same degree or not, same number of neighbors or not. Right. So you pass the dictionary in the return statements. In the first code snippet, there is only one line of code that's in the return statement. So just see what is happening in this part in the list comprehension. What am I doing? This f of graph, comma v for every v in the graph. What does this do? F returns what? F function for every vertex?
Find the number of neighbors.
Number of neighbors. So if I find the number of neighbors for every vertex, right, and put them in a list, and then I apply set function on them, what does set do?
Remove the elements which are not useful.
So does set allow duplicates?
No.
That means if all the vertices have the exact same number of neighbors, then after applying the set function, how many elements will be there in the list?
One.
Only one, because set will not allow you to have those 8 copies of the same number, right? Same number of neighbors. It will only allow one. That means if the length of this set is 1, so that's what I'm comparing. That length of this set, is it exactly equal to 1? What does that signify? That every vertex has same number of neighbors. So all the duplicates were removed by the set function. So is this a correct code to check? First tell me one thing. If
Yes,
I
ma'am.
if I compare like this, what does the return statement actually return? If this is true, it will return a true value, right? Boolean. I'm doing comparison. That is the length of the set exactly equal to 1. If it is, then it will return true, otherwise it will return false. So this is a correct code. Now again, what another implementation of this is what? Def is regular graph. Okay. In the second snippet now, see. In the degrees, this variable, what have I stored? Just tell me what is this list?
All the degrees of various vertices.
Degrees of every distinct vertex, right? Now common, in the common variable, what have I stored? Degrees of
0.
0. What is that? Degrees of 0 means the first element
First
in the
one.
list. So in degrees list, I have stored the degrees of every individual vertex, and then in common variable I'm storing the first element from the list, that is the first degree. Now I am running a for loop that I will go through each of the elements in this degrees list, and I'll check whether it is not equal to common. That means what? I am taking the first element and I'm comparing it with every other element. So at any point if I find a mismatch, then can I say that it is not a regular graph? Because in case of a regular graph, all the degrees should be equal, right? So if there is a mismatch, I will return false. If there is no mismatch, I will come to the end of the loop and then return true. So is snippet 2 correct?
Yes, ma'am.
That means both snippets are correct, right? So this is the answer. Both snippets 1 and 2 are correct. Anyone who didn't understand this?
Ma'am, I can understand the second one.
Second one, see, same exact same thing is happening. So instead of doing all of that in a single line, what we have done is, instead of using the set function, we have used just common comparison. Okay, so first I have created that degrees list. This is a list of degrees of every individual vertex in the graph. Then in the common variable in line 3, I have stored the first element from that list. So if it is a regular graph, that means every degree should be equal, right? So the first element should, if I compare it with all the other elements, should be equal if it is a regular graph. So that's what I'm doing. I'm taking the first element and I'm comparing with every other element in this for loop. And at
Got it,
any
ma'am.
point, if I
Yes.
find there's a mismatch, then return false. It's not a regular graph. Okay.
Got it. Thank you.
Yeah. So snippet 1, snippet 2 both are correct. Now another question from the same, this is a comprehension type question. So 4, 5 questions from the same data. Now, a complete graph is a graph in which there is an edge between any pair of vertices. That means a complete graph will let you reach any vertex from any vertex, right? Because there is an edge between every pair. So is complete is a function that returns true if a graph is complete and false if a graph is not complete. So we have to again complete that function. So what did I say? That if from every vertex to every vertex there is an edge. So again, in our example, we have 8 vertices. So for a particular vertex to be connected to all other vertices, how many edges should it have?
V minus 1.
Sorry, come again.
Minimum
See,
of vertices,
see,
vertices minus 1.
just say it mathematically. I have 8 vertices. Then I pick one vertex and I want that there will be an edge from this vertex to every other vertex. So how many edges will be there?
6.
7.
7. 8 vertices are there. I pick one out. How many are remaining? 7 are
Oh,
remaining.
sorry,
So
7.
from
7.
this one, I need 7 other edges to 7 different vertices. Right. This is the only thing you need to understand. Now see the implementation here. So according to the question, for it to be a complete graph, let's say I have a graph with n vertices. If the graph is complete, then every vertex has n minus 1 edges. Correct. So snippet 1 is saying definition of is complete. It is passing the dictionary of the graph. And it is returning what? Again, see the same list is there, right? F of graph comma v for v in graph. This is giving you what? Degrees of all the vertices. So this is a list of degrees of all vertices. And I'm taking what? The set, right? So again, what does set do? Remove all duplicates. So like I said that if I have n vertices, what should be the degree of every vertex if it is a complete graph?
N minus 1.
N minus 1. Set will remove all duplicates. So how many entries will be there in the list in case of a complete graph? Only one entry. What is that entry? N minus 1 in case of a complete graph. And what am I checking it with? G of graph minus 1. What does G of graph? What does this function return? Check the function definition again. G of graph returns length of graph. That means how many entries are there in the dictionary. So if there are n vertices, how many entries are there? N entries. If there are n entries, then that minus 1. That means n minus 1. So if these two values are equal, then I can say that it is a complete graph. Yes or no?
Yeah.
Right. This part, see, if anyone didn't understand, listen again. This part, okay. Just focus on this. So first in the list, we are finding what? That how many neighbors does each of the vertex have, right? So if there are n vertices, there will be n such entries in this list. If it is a complete graph, all the entries should be same, n minus 1. Now why we are using set is so that we can get rid of all the duplicates and there remains only one entry, which is n minus 1 in case of a complete graph. So that should match with this g of graph minus 1, which is also n minus 1. So only in this case I can say it is a complete graph and this will return a true value. If it is not, then it will not give a true value, it will give false. That means it's not a complete graph. So is snippet 1 correct?
Yeah.
Come to snippet 2. So def of is complete graph, it is just returning whatever is regular returns. So is regular and is complete the same thing? Regular graph and complete graph are same things? Regular graph means all vertices should have same number of neighbors, but it is not saying that all of them should have n minus 1 number of neighbors. It is saying same number of neighbors. So is it same, complete and regular?
No.
So
No.
snippet 2 is false, right? Only snippet 1 is correct. Snippet 2 is to check whether the graph is regular or not. Of course, every complete graph is a regular graph, but every regular graph is not a complete graph, right? The idea is that regular graph means that every vertex should have same number of neighbors, but in case of complete graph, every vertex should have same number of neighbors, and that number of neighbors should be n minus 1 if there are n vertices. Okay, so this is the superset. Regular is the superset, complete is the subset. So this is not equal. Snippet 1 is correct, snippet 2 is wrong. Okay, now this graph problem is over. Now we'll go from problem 6 to 9, again common data. So look at this list. So this is saying that we have a list L of positive integers with at least 2 elements. Okay, 1 second. Yeah, okay. So list L of positive integers with at least 2 elements in it, right? So the first function is P of L. So this function P, it is taking L as its argument, right? Now A is a variable which is assigned 0 for I in range length of L. So that many iterations, as many as there are elements, right, in the list L. What am I doing for every iteration? If L of I is not in, so what does this slicing operator mean? What is this? Colon I.
Start to end.
Okay, let me put it this way. If I say that my list has 10 elements, okay, list L has 10 elements, currently I is equal to 4. So what does L of I, L of colon 4 mean? How many elements will I see?
3. The
3.
first 3.
Right. So the number of elements before that fourth element, right? So if I see that L of I is not present in this list of elements, then A is being incremented. And at the end, I am returning A. Now, what is the question that's been asked, that what does PL return after the execution of the above code? So this is very simple. Now understand, if I am checking the 10th element, okay, and I see that it is not present in the rest of the list, that means I can say it's a distinct element. So like this, I am checking for every element in the list, right? So for every element, I am checking if that element is present anywhere before in the list. So if it is present, then I can say that it is not a distinct element. It is a duplicate. So I am for every index I am checking that the element present at that index is a duplicate or not. If it is present in the list more than once or not. So what does A represent? L of I, if L of I is not in the rest of the list, then I am saying I will increment A. So
Number
what?
of distinct elements.
So A is number of distinct elements present in list L. Is it okay with everyone? Anyone didn't understand?
Got it.
Okay. So this is the first question. Total number of distinct elements in the list is the answer to this. Second one is again, what does Q of L return after execution? So let's do what is Q of L doing. So it is taking B equals to 0, and for every I, again I in range of L, it is checking if L of I is in the rest of the list. So if it is in the rest of the list, then I'm checking. So again, let's take it with a real example. If I is 5, okay, then I'm checking that if it is present in the indices that come before 5. If it is present, that means there is a duplicate, right? Now, if it is present, then you come to the nested if. If L of I not in I plus 1 till the end of the list. So what does this mean? What is
You're
this part
counting
of the slide?
elements. You're counting elements which appear exactly twice.
Okay. Any other ideas? Or everyone agrees with this?
Can you show options?
Okay. So which option does it come the closest to?
Option B.
Option B.
Option B. That means we need at least one repetition, right? Now, here we can see that B is being incremented when it is present, that is a duplicate is already present before the index I, but it is not present after the index I. Okay, so before index I there are duplicates. Now I don't know how many are there. That means I know that at least one more is there. Correct. So option B is the right answer, that total number of elements that get repeated at least once in the list. That means elements which have at least one duplicate present. Now let's do this R of L. So this one also you try to unpack the same way. First we have two variables x0 and c0. So what is uh, this code doing? Just look at it once yourself before I explain this. Just try to understand what's happening here. What is the for loop in the if else statement? What am I trying to accomplish? What are these comparisons for?
The largest value.
Correct, the largest value. So we can see that I am constantly checking if the next value is bigger, right, than the current value. And then I'm doing some kind of updating. But I can see that for to find the maximum value, we need only one variable. So x or c alone would have been enough. So why am I taking both variables? That's the question. So see, think of it like this, that in this first if statement, right? So x here, what basically I'm doing is x is supposed to be storing the second largest value that I have seen so far, and c is supposed to be storing the largest value I have seen so far. Okay, that's the idea. So what happens that I am scanning the entire list from left to right by using this for loop. Now in this line 20, that if L of I is greater than C, so that means if the current item beats the current max, right? C is what? The variable where I'm supposed to store the max, and X is the variable where I'm supposed to store the second max. So this will understand that how it is executing such that X stores the second max. So I can clearly see that if current element I am at, that is L of I, is greater than C, then C is being assigned L of I. That means C is keeping track of the maximum, whereas X is being assigned C, that is the old value of C, right? So first X is being reassigned and then C is being reassigned. Again, if the current value that I'm seeing is less than or equal to the current max, in that case, I have one more if statement, that is the current value also greater than X. So what can I say? If my current max is 80, let's say C is storing 80. Okay, and the current second max, that is X, let's say it is 70. Okay, now I have the value 75. So is the first if statement going to be valid? Is 75 greater than 80?
No,
No.
no.
I come to the else part and I check, is 75 greater than 70? Yes. That means can I say that 75 is the new second max? Can I say that?
Yes.
If max was 80, second max was 70, right? X is the second max, C is the max. C is 80, X is 70. My current element L of I is 75. So first I'm checking, is 75 greater than max? No, it is not. So nothing will be executed. Come to else part. Again, the if statement inside else is checking, is 75 greater than 70? That is second max. Yes. So you reassign second max. Max remains as it is. When does max get reassigned? When you find a value that is greater than your current max. So now you have understood what is R of L doing. It is finding the first max and the second max in a list L. So the question is asking, what does R of L return? So what is it returning? Return X. So what is X?
Second highest.
Second largest element of the list. This option. Is it clear for everyone?
Ma'am, but there is no need of else part now.
Which one? This else line.
Uh,
Why?
Yes, ma'am. Because anyhow it will replace the second highest means if Li is greater than C, so it will replace X equal to C and C equal to L of I. So X will be second highest anyhow.
Okay, but see the example that I gave. I understand what you're saying, that the current max, if it is replaced, it becomes the second max. Right? That's what you're saying.
Yes, ma'am.
But like the example I gave, that if current max is 80 and second max is 70, but now I got a number 75. In that case, will this if statement be enough? If L of I is 75, in that case, how do you update X? Because the current max is not getting replaced, but only the second max is getting replaced. The maximum value stays same, but second maximum value changes. That is the case when you come to the else part.
Yes, ma'am.
Okay. Okay. Now, if you understood this last one should also be easy to do. What is the S of L function doing? So here I can see that only D is the one variable which is assigned 0. Now, for I in range length of L, that is, I'm going through all of the elements in list L. If L of I is not in this slice, so what is this slice? That means rest of the list, all of the indices that come before I, right? So if L of I is not present in those elements, then Y is 1. Y is set to 1. Okay. And next I can see in the else part, that is if L of I is present, that is if there is already a duplicate of L of I, then I am checking if L of I and L of I minus 1 are not equal. That means the duplicate of L of I is not present in the previous index. In that case, you again set Y to 1. There is one more else, that is the nested else, which will be true when L of I has a duplicate and the duplicate is present in the I minus 1th element. In that case, Y is just incremented. And then there is one more if inside the else, that if Y is greater than D, then Z is assigned L of I and D is assigned Y. So a lot of assignments or a lot of comparison things are going on. So let's break it down step by step, right? So D is something that I am, what am I returning? Z. So D is basically something to keep a count of, right? D is a variable that gets updated with what? With Y. So D is keeping track of something that Y is calculating. Okay. So what we are doing is we start a counter. Okay. For every element that we see, every L of I that we see, we start a fresh counter for that. Okay. So let's say I am at index 5. I is 5, I am at index 5. So I am checking that the value at index 5, has it appeared before also? If it hasn't, if it's the first appearance of this value, then you set Y is equal to 1. This is the fresh counter. Okay, fresh counter that has been set for this value. That is, there has been one appearance of this value so far. So obviously you are not coming to the else part, right? Now let's say I go to the next index, that is index 6. And whatever was present in index 5 is the same value that is present in index 6. That means the if statement will fail here because current L of I is already present. There is a duplicate. So you come to else part and you check, is the current index and the previous index carrying the same value? So they are carrying the same value in this case.
Can you once again repeat the second iteration?
Yeah, see. In first iteration, I said that I is equal to 5. So there was some value that is present at I is equal to 5. That is L of I value that I'm checking. And I'm saying that let's say this is a fresh value that is not present anywhere beforehand in the list. Okay. That is not part of any of the indices we have seen so far. So it is a fresh value, unique value. So Y is set to 1. That is a fresh counter. Okay. Now in
Okay.
the second iteration, when I go to the sixth index, I see that the value present at index 5 and index 6 are equal. In that case, the first if statement will fail because a duplicate is present beforehand. So you come to the else part and check if L of I is not equal to L of I minus 1. This will also fail because index 5 and index 6 are carrying the same value. Your current I is 6, I minus 1 is 5. They are having the same value. In that case, this fails. So you come to the else part here, nested else. And you increment Y by 1. So now Y becomes 2. That means we now have two occurrences of the same value. So initially D was 0. Now I see that 2 is greater than 0. Right. So D is now assigned the value 2 and Z is assigned L of I. So what does this signify? L of I is the value that I'm keeping track of, that how many times this value has appeared, that I am storing in Z. And D is keeping track of the number of times it has appeared. Okay. So when do Z and D get updated every time? When I find a new Y value that breaks the previous record. So what is happening? See, in every step I'll tell you what is happening. D is basically the longest consecutive run for any value. D is storing the longest consecutive run of any value. That is longest number of times a value has been repeated consecutively. That is what I'm storing in D. Okay. Now first we check that for every value, as soon as we start an iteration, we check that the current value at this index, has it appeared before or not. If it is a fresh value, then we start a fresh counter for it. Now if it is not a fresh value, then we see, have we seen this value before? Yes, but was the previous item the duplicate one? If that is not true, that is the ith element and the I minus 1th element are different, then again we have to start a new run. Understood? Because we want consecutive duplicates. So that's why we are checking this second condition in the else, that is L of I not equal to L of I minus 1. In that case also you have to start a new counter. Again initialize Y to 1. But if you see that, yeah, the previous value is also same, that means no new counter is needed. We are still doing the same run for the same value. So we can just update Y like this. And as soon as we find that Y is a record that is breaking the current record that is present in D, that is, let's say some value appeared 3 times in a row, but after that some value is appearing 4 times in a row. So that is the new record. So D has to be updated to that 4. And Z keeps track of what is the value that is setting the record. Let's say the value 5 appears 3 times and the value 6 appears 4 times. So 6 will be stored in Z and 4 will be stored in D. And what you are returning is the value that has the longest run, longest consecutive run. So what does S of L return? Which of these statements look true?
Second option.
First element, which is consecutively repeated maximum number of times in the list. Right, because see, when am I updating D? When the record is broken, it is not greater than equal to, it is only strictly greater than. That means if there are two such values which are repeated the same number of maximum times, only the first repetition is recorded, not the second one, because greater than equal to is not there, strictly greater than. So the first element which is consecutively repeated maximum number of times in the list, this option is correct. Is it clear for everyone?
Yes.
Okay, if it is not clear for somebody, then you just generate a random list with duplicate values which are consecutively present, and you can do a dry run of the code. Okay. Now, everyone is familiar with what is Fibonacci sequence. So Fibonacci sequence means
Yes.
what? We start with 0 and 1, right? These are the first two default values, and then the third value is the summation of the last two values, that is 0 plus 1 is 1, 1 plus 1 is 2. Like this you can extend up to n number of whatever you want n to be. So if I say give me the first 5 Fibonacci numbers, so that will be 0 1 1 2 3, right? So I want you to find out that which of these implementations is correct to find I mean which of these implementations will give you the first 10 Fibonacci numbers starting from 0. So there are three codes, you have to tell me which one. So let's see the first one. So what is happening here? So for I in range n, basically this is the first start of your program. So you're going, let's say I want first 10 Fibonacci numbers, so I will go from 0 to n minus 1, right? That is the first 10 numbers. For every I am doing print fib of I. So then the control shifts to the actual function, that is this. So what is the function doing? Let's say I is currently 3. Okay, I is 3. So I starts from 0 0 1 2 3. So let's say I is currently 3. For that, what am I doing? A and B are assigned 0 and 1. Okay, now for I in range 0 comma n, so n is what, 3 right now. Okay, so how many iterations will be there? Okay, if you want, we can start from the beginning. Let's say I am at the 0th iteration. That is first iteration when I is 0. So print fib of 0. This will give what? A is 0, B is assigned 1. For I in range 0 to 0, will there be any iterations?
No, ma'am.
So return A will return what? 0 itself, the value of A. Now let's go for I is equal to 1. So fib of 1. Again A is assigned 0, B is assigned 1. For I in range 0 to 1. 0 to 1. So now there is one iteration that's going to happen where A is now storing B, which is 1, and B is now storing A plus B, which is also 1, and you return A. So the second number is printed, that is 1. Now I is 2. Okay, so I is 2. So A is 0, B is 1 again. For I in range 0 to 2. How many iterations? Range 0
3.
to 2 means
Two iterations.
2 iterations. That means I will be 0, I will be 1. So first iteration, uh, okay, let me write this. It will be better. Just a second. Okay, can you see the PDF? Blank PDF.
Yeah.
Okay. So let me just do that iteration again. So see, this is the code, right? That for every iteration of I, A and B are swapped with values where A is set to value B and B is set to A plus B. There is summation, and at the end we return A after all the iterations are done. Okay, so let's write that for I in range 0 to n, what do we do? A and B are set to B and A plus B, and at the end, you have to return A. So I am currently trying to find for I is equal to 2. So how many iterations did I say will happen if the range is from 0 to 2?
2 iterations.
Two iterations. So let's do the first one. For first iteration, A value is, remember, A is initially 0, B is initially 1. Okay. So for first iteration, A is now set to B. What is B? 1. B is now set to A plus B. What is A plus B? 0 plus 1, again 1. Now let's go for second iteration. Now A is 1, B is 1. Okay. Now A is set to B again, which is 1. B is set to what?
2.
1 plus 1, 2. There will be no more iterations. So return A will return what? 1. So we had already done previous two iterations. See, my n is, I am trying to find first 5 Fibonacci numbers. So for first I value 0, I have found that 0 is printed. Then second I value 1, I have found that 1 is printed. Now when I value was 2, I find that again 1 is printed. Now when I is 4, I is 3, I'm sorry, I is 3. Okay. So let's update the range. So now how many iterations will be there from 0 to 3?
3 iterations.
So let's add one more iteration. Everything will be same up to this. Now A is 1, B is 2. So next A becomes set to current B, which is 2. B becomes set to A plus B, which is
4.
3.
3.
3.
3. Right. Now what is being returned? Return A. So what is A? 2. That is the fourth Fibonacci number is being printed. Now next iteration is for I is equal to 4. That means the range now changes from 3 to 4. So again, how many iterations will happen? 4 iterations. 0, 1, 2, 3. Right. So we have done the first 3 iterations. Let's do the fourth one now. So at this point, A is to B is 3. Right. Now A is set to B, which is 3. B is set to A plus B, which is 5.
5.
And return what? A value. So 3. That is the fifth Fibonacci number. So 0, 1, 1, 2, 3. This is the first 5 Fibonacci numbers. So is this a correct implementation?
Yes, ma'am.
Yes.
So first code snippet is correct. Now let's look at the second one. In the second one, see what is happening. Again, this part is same for I in range n. Every time you print Fibonacci of I. Okay. So for Fibonacci of I, let's say if I want to again print the first 5 Fibonacci numbers, so I start with I is equal to 0. For I 0, that is if n is equal to 0, you directly return 0. So 0 is printed. Again, if for next iteration when I is 1, if n is equal to 1, you directly return 1. So 1 is printed. First two numbers are directly printed. Now let's come to when I is equal to 2. In that case, this return statement will be executed. That is Fibonacci of n minus 2 plus Fibonacci of n minus 1. So let's unpack that here. So fib of n minus 2 plus fib of n minus 1. Remember, fib of 0 was 0 and fib of 1 was 1. So now when I come to fib of 2, for that I have to do summation of these two. So 2 minus 2 is what? 0. Fib of 0 is 0. 2 minus 1 is what? 1. Fib of 1 is 1. So 0 plus 1 is giving 1. So what is the third number that will be printed? 1. Okay. Now next iteration we want fib of 3. So again it will come to fib of n minus 2 plus fib of n minus 1, where n minus 2 is 3 minus 2, which is 1, and n minus 1 is 3 minus 1, which is 2. So what is fib of 1? 1. What is fib of 2? We already found, again 1. So 1 plus 1, 2 is printed. Now last one, fib of 4. So Fibo of 4 minus 2 is
Above 2.
2, and Fibo of 4 minus 1 is 3. So Fibo of 2 is 1, Fibo of 3 is 2. So 1 plus 2, 3 is printed. So what are the numbers printed? 0, 1, 1, 2, 3. Is this correct?
Yes, ma'am.
Yes, ma'am.
So second code snippet is also correct. This is an MSQ clearly, but there is one more. 3 code snippets are there. So in this one again check the line 7 and line 8 are not same here. So what is happening for every I in Fibo of n we are printing print of I. For I in Fibo of n print of I. What does this mean? For I in Fibo of n, what does this line mean? Fibo of n. That means, let's say again, I am passing this n is 5, right? So for I in fib of 5, you are
Function.
printing I. So whenever you pass fib of 5, it just goes back to the function definition, right? And it here only, see in this line 1, here in line 1 till line 5, this is nothing but the Fibonacci series you are printing, right? So here you are not doing one by one, you are just passing that I want first 5 Fibonacci numbers, so fib of 5. A is 0, B is 1, these are the starting two, and then you go from for I in range n, yield A and B are swapped again with B and A plus B. So at the end of all of the iterations, I will have the first 5 Fibonacci numbers, right? And you are just printing them one by one. So here there are not multiple function calls, instead there is a single function call, you are just printing the values one by one. See, here we have seen one new statement, which is what statement we have seen new here?
We are
Yield.
calling function for loop.
The yield keyword, what does it do?
Yield.
In Python, yield keyword does what? It creates what? Generator functions. Right. So unlike any regular function that uses a return statement to send a value and terminate, a generator function that uses yield, it produces a sequence of values one at a time. Right. So it will pause the execution after each yield statement and resume from that point when the next value is requested. That means every time you yield a value, so the execution is pausing for some time. Right. So basically what you are doing here is that you are generating all of the Fibonacci numbers in this one call of the function only, and you're printing them one by one. So is the third snippet also correct?
And can you please explain this also in by using example?
Yeah, look. First see, in the code I can see that A and B are set to 0 and 1, and then for I in range n, so first A is 0, B is 1, for I in range n. So I can see that yield A, and then A and B are set to B and A plus B. Right. So what is the difference here? We have seen that this is the correct logic behind Fibonacci, but here the print statement is different. So in the outside, in the main program, I have seen this is the definition of Fibonacci. In the main program, I have seen that for I in fib of n, print I. This was it, right? That means for each of the values that are being generated in this definition of the function, you have to print that value. So what are the values that are being generated? First value of A is what? In the 0th iteration. So if n is 5, how many iterations will be there? 0, 1, 2, 3, 4. These many iterations. When I is 0, 1, 2, 3, 4. So for I 0, what is A? When I is 0, what is A? For first iteration. What are the initial values of A and B?
0.
Initial value A is 0, B is 1. So So when I is 0, A hasn't been changed. A is still 0. So that is the value we are yielding, yield of A, right? This is a keyword in Python, yield keyword. It is used to create generators, which are nothing but special type of iterator. Okay. So it will allow the values to be produced. Basically, you can say that the values are produced in a lazy manner, that is one at a time. Instead of returning all the values at once, you return the values one at a time. So this makes yield useful for what? When you want to handle, so basically this is used for large data sets, right? So it will you allow you to iterate through the values one by one. But basically what it is doing is when you do yield of A, that means only the value A is generated. Now A and B are changed. So what is A now?
1.
B is 0 plus 1,
0 plus 1.
again 1. So when you go for the next iteration, when I is 1, what will be the value that will be yielded for A? 1.
1.
So first value yielded was 0, second value yielded is 1. Again, A is now changed to B, which is 1, and B is changed to 1 plus 1, 2. So third value of A that is yielded is again 1. Fourth value, A is now 2, B is 2 plus 1, 3. Fourth value of yield of A is 2.
2.
Then last iteration, A is now 3, B is 5. So last value yielded of A is 3. So is this valid sequence?
Yes.
Again, same. So what we are doing is instead of calling the function multiple times, we are calling the function once only. Okay, so n is 5 in the beginning only. Fibonacci function will run only once, but the values will be generated one by one due to this yield statement. And once the values are generated, then I'll just, what am I doing in this for statement? That for I in Fibonacci of n, that means every time a value is being yielded, you're printing that value. So first 0 is printed, then 1, then 1, then 2, then 3. So the valid Fibonacci sequence is being printed. So is it correct implementation or not?
Yes.
That means all three are correct, right? So all three of the implementations of Fibonacci are correct here. Okay, for everyone it is clear, right?
Yes, ma'am.
All right, now this one. This is also, I think, comprehension. Yeah, 11 to 13. These are same types of questions. Okay. So look at the code. So f is a function that accepts a positive integer n as argument. So f of n, if n is greater than 1, then what you are checking is, okay, what is this thing? Double star. What does this represent in Python?
Square of the number.
Square of a number. So no, I'm just saying what is the double star operator? It is
Power.
power operator, right? So n raised to some power 0.5, that means power half. So anything raised to power half is square root of that, right? So if n is greater than 1, then what you are checking, that if the square root of that is equal to what? The square root of a positive number. So int of n raised to power 0.5, then you return 1 plus this f of int n raised to half. Else if, that is if, so first tell me this line, that line 3, what is this checking?
It's an integer.
Check clearly, what is this checking?
Whether it is rational?
Okay, rational. Where is the rational concept coming from? Rational is any p by any number I can express as p by q.
No, because you're taking square root over there. And you're
Is
checking, I
n
mean,
is
if
n
it
is
is an
the
integer.
perfect square or not?
So it is checking if n is the square of a positive integer. Just give me a second, I'm getting a call. Yeah, okay. Yeah, so I was saying that what is this line 3 checking, right? So it is a way to check if n is a perfect square or not. So n raised to power half, it computes the square root of n. An integer of that converts it to what? The square root to an integer value, so it gets rid of any decimal part, right? So if we compare them and the square root doesn't have any decimal part, then it is an integer. So I can say that n is basically, it is checking whether n is a perfect square or not. Okay. So if it is a perfect square, then what is being written? 1 plus f of square root of n. Else, if n is not a perfect square, then I'm checking if n percent 2 is not equal to 0. That is, what does that mean? N percent 2 not equal to 0. So what is n? What can I say?
N is odd.
Odd.
N is odd. Then I'm returning what? 1 plus f of 3 into n plus 1. Again, last else statement. I'm just doing a return that if n is not a perfect square, if n is not odd, then you come to this else statement and return 1 plus f of int n by 2. Okay, now these three statements are clear. What is happening now? If n is not greater than 1, in that case you come to this line 9, elif. If n is less than 1, so there are three possibilities: either n is greater than 1, or it is less than 1, or it is equal to 1, right? So if n is less than 1, then you return 1 plus f of n square, else you return 0. So this is everything that is going on in this code. Now the question is asking you if n raised to power 0.5 is equal to int of n raised to power 0.5. Conditional statement checks if n is a square of any positive integer or not. So if is this statement true? Is this what it is doing?
Yes.
So it is true, right? It is checking whether n is a square of any positive integer. That's what I'm doing. If it is a square of positive integer, then only the square root will give a whole integer. So this is a true statement. Second one is saying, question 12 is saying what is the value returned by f of 10,000. So this one, let's do it manually. Let's write down. Okay. So f of 10,000. That means which one of the is line 2 correct? Is n greater than 1? Yes. 10,000 it is. So let's write down f of 10,000. So this is our n. N is greater than 1? Yes. So now what do I check? Again, go back to the code. It is checking if it is a perfect square, if it is a square of a positive integer. So is 10,000 a square
Yes.
of
100.
100.
right? So this will give true, right? So the if statement in line 3 will give true. It is a valid if statement. So we will return what? 1 plus f of what? Do the square root of 10,000. What does it give? 100. So return 1 plus, this is recursion. So return 1 plus f of 100. Up to this everyone agrees? Right? Anyone who didn't understand till now? So this is the first call. Okay, we'll come back here. But now the control has shifted to this execution. So again you check, is this greater than 1? Yes. Is 100 a perfect square of any positive number?
10.
10. So again yes. So what will you return? 1 plus f of
10.
10. Now control shifts here. This is the second call. Again check for f of 10. Is 10 greater than 1? Yes. Is 10 a perfect square of any positive number?
No.
No. So here the difference is there. So next, if that is not true, then what do we check? That if n is odd. So is 10 odd? No.
No.
So come to the else statement in line 7. Return 1 plus f of n by 2. That is,
5.
5.
so we will return 1 plus f of 5. Again control shifts here. This is the third call, third recursive call. So now f of 5. Okay. Is it greater than 1? Yes. Is it a perfect square? No. Is it odd?
Yes.
Yes. So if it is odd, then what should I do? Return 1 plus f of 3n plus 1. That is how much?
That's 16
So 1 plus f of 16.
again.
So this is going to be return 1 plus f of 16. Is 16 a perfect square?
Yes.
Yes.
This is the fourth call. Now we are doing for 16. So again, greater than 1, yes. Perfect square, yes. So what am I returning? 1 plus f of, what is the square root of 16? 4. Fifth call. Now control shifts to f of 4. Greater than 1, yes. Perfect square?
Yes. F of 2.
Perfect square also, yes. So return 1 plus f of 2. Sixth call.
0.
Now you go for f of 2. F of 2 is greater than 1, yes. Is it a perfect square?
No.
No. Is it odd?
No.
So what is left?
Plus
N by 2. That is 1 plus f of 1. So return 1 plus f of 1, that is,
it is not greater than
come here now. What is f of 1? Is it greater than 1? No. So then you go to the else part. Here, elif. Is it less than 1? 1 is less than 1?
No.
No. So come to else part, directly return 0. So this is the end of our recursive calls. So from here, what will be written from f of 1? 0. 0 plus 1 will give 1. This comes back to the last call. Here, 1 plus 1. This returns 2 to the fifth call. 2 plus 1 returns 3 to the fourth call. 3 plus 1, 4. Again return back 4 plus 1, 5. Again return back 5 plus 1, 6. Lastly return back to the first call, 6 plus 1,
7.
7. So 7 is the answer. So this one for 10,000 will return the value 7, NAT type. This is clear for everyone?
Yes.
Okay. Now same thing you can do for f of negative of 8.
Sorry, ma'am. After 0, I didn't understand. Once it returns 0,
Once it returns 0, then you don't have to do any more recursive call. Now you just backtrack to the last calls. So once it returns 0, what is the last call? This one, return 1 plus f of 1. So f of 1 returns 0. So return 1 plus 0, that is 1. Where are you returning it? Back to the sixth recursive call here, f of 2. So it was 1 plus f of 2. So f of 2 is now 1. F of 2 is returning 1. So 1 plus 1 is 2. So again, this was, where did we get this statement? When we broke down f of 4. So this goes back to f of 4. So 1 plus 2 is 3. Again, this 3 value goes back to f of 16. So 1 plus 3 is 4. Like this, you have to backtrack till you reach the first recursive call, that is f of 100.
okay.
Right? Every time you backtrack, you have to add and then again go back to the previous recursive call.
Okay, ma'am. Thank you.
Okay, now similarly, this one you can execute for f of negative of 8. What should be the case in this? If I do negative of 8, is it greater than 1? No.
10, 0.
Is it less than 1?
Yes.
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 So go to that possibility. If it is less than 1, then what do we do? Return 1 plus f square. What is minus 8 square? 16? Yes or no?
Yes.
I'm sorry, minus 8 square is 64.
60.
Okay, why saying yes? Say 64. So this f of negative of 8 will give us return 1 plus f of 64. Now go to this. F of 64 greater than 1. Yes. Is it a perfect square? Yes. So you will return what? 1 plus f of 8. Go to 8. Is it greater than 1? This is first recursive call. This is second recursive call. Greater than 1. Yes. Perfect square? No. So next what do we check? If it is not a perfect square, is it odd? 8 is not odd. In that case, lastly, what is the condition? That if it is not a perfect square, if it is not odd, then what do we do? Return 1 plus f of int of n by 2. So 8 by 2 is 4. So here it will be written 1 plus f of 4. Go to f of 4. This is third recursive call. So f of 4. Again greater than 1, yes. Perfect square, yes. So return 1 plus f of 2. 2 square is 4. Again f of 2. So what did we calculate last time in f of 2? What was it returning?
1
F
plus
of 2,
f
if I
of
broke down, it was giving 1 plus 0, that is 1. Right?
no f of 2 returns
F of 2 returns 1. Because ultimately it breaks down to 1 plus f of 1, where f of 1 is 0. So 1 plus 0 is 1. F of 2 is 1. See this part? F of 2 greater than 1, yes. Perfect square, no. Odd, no. So what is left? 2 by 2, that is 1. So 1 plus f of 1.
yes.
And f of 1 will always give 0. So 1 plus 0 is 1. So f of 2 will return 1. So 1 plus 1, 2. This gets to go back to the last call, that is f of 4 here. 2 plus 1 is 3. 3 goes back to the second call. 3 plus 1 is 4. 4 goes back to the first call. 4 plus 1 is 5. So 5 is the answer for f of negative of 8. Clear? See, these things are very simple. You just have to do a dry run. Okay. And just know how recursion works. It is always return back the value, complete the operation, then go back to the last call. So for this question 13, the answer is 5. This 11 to 13, all questions are clear for everyone? Any doubt? Okay. I'm audible, right?
Yeah.
Okay. So now let's come to some different types of questions. So L is a non-empty list of distinct integers that has already been defined. Now which of the following recursive functions returns a sorted list in ascending order? So again, L is just a list of non-empty list of distinct integers. We have to find out that which of these recursive functions will return a sorted list in ascending order. That L will be returned as sorted L in ascending order. So again, this is MSQ. So look at how many options are there. 4 options are there. First one, let's see, sort of L. So sort is the function, L is the parameter. You pass the list and you check if the list is not empty. Only then we will start sorting, right? So here in max index variable, I'm storing L of index of max of L. That means what is this part? Max of L will find the max element in L. So L dot index of that element will find the index at which the max element is stored. Right? So this index of the max element is being stored in max index. Now L of max, that is the max index element, the element which is stored at the max index, that index. So L of max index and L of negative 1. What is L of negative 1?
Last element in the list.
Last element in the list. So if we swap them, what happens? The maximum value is now at the end of the list, correct?
Yeah.
And the value that was at the end of the list is now at the max index. So it is being swapped. So this is correct, right? If I want a list to be sorted in ascending order, obviously the highest value will be at the last index. Okay. So that last index is now sorted. Now return what? L of -1 to end of list. What does this mean? -1 to end of list?
Negative last
Is,
element of the list.
yeah, that means only the last element, nothing else. Plus sort of, that means this is a recursive call. So sort of L of colon -1. What does this mean? Colon -1? Everything that comes before
Before
the last
last
index.
element.
So that means it will recursively call the list, and every time what you are doing is find, you have a shorter list and you find the max index, place it at the last index, and then again remove that last index, call the rest of the list for sorting again. And every time you're concatenating the last index at the front. So is this correct? Should I be concatenating the last index at the front? This L of -1, this is the last element in the list. L of -1 colon. So this should be at the end, right? This index should be at the end. So whatever the sort of the rest of the list returns, it should be added to the end of that. So is the first option correct? See, very simple thing is happening. We are taking the max element and the last element and we're swapping them so that the maximum element stays at the last index. That's what we want, to sort in ascending order. Okay. And once that last index contains the max element, we remove that and we take the rest of the list and sort it now. So that last element that I removed should come at the end of the list or at the starting at the list.
The end of the list.
End of the list.
So is this concatenation correct here? This return statement is correct.
No.
So the option is wrong. But look at the second one. Is this one correct? Everything is same except for the list concatenation part. Here the last element is being added to the end only.
Yes.
So this is the correct option. Now if you check the other two, these two also are very similar. Here what we are doing, see, two types we can sort, right? One thing I can do is I can find the max and put it at the end, or I can find the minimum and put it at the beginning, right? So if I put it at the beginning and then sort the rest of the list, then the beginning element should come at the first of the list or the last of the list while concatenating.
First of the list.
So option 3 is correct or option 4 is correct? Look, min index and L of 0, that is first element and element containing minimum value. These are being swapped. Index containing minimum element. These are being swapped. That means now the index that contains the minimum element is swapped with the first index value. So at L of 0, now we have the minimum element present. So minimum element is sorted. So this minimum element should come at the beginning or at the end?
Beginning.
While beginning. So which one is correct? L of sliced 1 or then concatenate with the rest of the sorted list? Or first you have the rest of the sorted list and then put L of, that is the first element at the end?
Third option is right.
Third option is right. So which options are correct? 2 and 3. Okay, this problem just looks difficult. You don't have to solve it even if you are familiar with slicing. Okay, now after this there are mainly, we have yeah, this is a good question. 1 second now. Okay, see this one now. Question 15 is visible to you?
Yes.
Okay, so you just have to find out that what is this returning? What is this going to return? See, foo of k, where k should be 10, because we are asking that what will foo of 10 return. So if k is 10, then parameter k equals to 10. Now what we are trying is, if try block, what is the first statement? K equals to p. But is p defined anywhere in the code before this?
No.
P is not anywhere. So what kind of error does this give you? Execution will jump to where? It will immediately go to the except name error, because this is a type of name error, right? Because p is not defined anywhere. So when you assign p to k, this is an error. Immediately it will raise a name error before anything else can run. So this will raise a name error. And when you go to this except block for name error, what do you return? Name error. So what will this code, entire code return? Name error. This type of question, if you're just familiar with what are these different types of errors, name error, value error, syntax error, when all of these are triggered, you can easily solve. Okay, I think this is just 1 mark for this. Yeah, just 1 mark for this question. Nothing to solve here. Okay, now this is a good question. See, this if you can get, you will know that you understand OOPS concepts. So this is a class test. Everyone knows OOPS, right? Object oriented part of it. Clear to everyone what is object, what is class? Is it, have you studied all this, or is it new? Am I audible?
New.
Yeah.
Okay, so object oriented part has not been discussed with you.
If you give a brush up, like it will be good.
Class
Okay.
is not included in syllabus, I think.
Uh, See, it was written. I was asked to discuss this mock, but mock contains everything. Okay, fine. I'll just give a brief about it. Okay, you don't have to come if you don't completely understand. It's fine. I'll just give a brief of what is class, what is object. So here, the code that you can see, we are creating a class called test. Okay, so any object of this class will have these characteristics. Okay, whatever is defined in this init function, you can see this is a constructor. So every time an object of the class is created, this constructor function will run by default. So here we can see that self dot variable. Self is nothing but an instance. Okay, instance of a variable, instance of an object. So for every object there will be something called a variable in which I have stored old. Okay, and self dot change, where I have passed self dot variable. So what is this change? So you can find this function definition under class only. Okay, tell me, is this part discussed at all? This class object part, has it been discussed with you?
Don't think so.
Do you have access to the videos of this or PDFs of this? If it is not discussed, or if you haven't studied this, then I won't be doing these last 4 questions because you won't understand.
No,
Okay.
class is not in syllabus.
Okay, then leave it. Then there is no need to go through these questions. You are all qualifier students, right?
Yes, ma'am.
Yes.
Yes.
Okay. Then I don't think you have this part. It is fine. We don't have to do. Okay, this one, let's see. I think this we can do. Yeah, this question we can do. So L is empty. Okay. This file handling you have done? Have you done file handling?
No.
Yes.
Okay, someone is saying yes, someone is saying no. Is it discussed with you in any previous session?
It's in the syllabus.
It's in the syllabus. Okay. Okay. Then we will discuss question 18 also. One second. I need to confirm all this. Fine, let's first do this. So the code you can see is f is equal to open hello.txt w. What does this first line mean? Anyone can tell me? That means we are opening this text file hello.txt in write mode. That is, we can modify something in this file, right? And f.write, what is f.write doing? Hello world, are you okay? Sorry, how are you today? So hello world, how are you today? So this line is now being written to this hello.txt file. Okay, and then you have f.close. That means close the file. Again, you have opened the same file in read mode now. That means you cannot modify anything in the file. You can just read from the file. And in data variable, you have assigned f.read lines. That is, read the data present in the file one line by one line. Okay, read lines means you read the data present in a file line by line. So for line in data, that is, it will go through all of the lines in the file, first line, second line, like this. Words is equal to line dot split. What does this line dot split mean?
Splits each word in a line.
So that
That
means
is space.
you are splitting by space.
Space.
Correct. So in this sentence, hello world, how are you today? Right? If I split by space, then in the list of words, how many words will be there? Distinct elements will be there. If I split by space.
6.
Hello is an element, world is an element, how is an element. All the words are distinct elements, right? So that is going to be present in this words list. And then you are doing print words and f dot close. So what is going to be printed in all of these options?
C.
Option C. This list is printed. Okay, this is a very basic file handling question. I don't know how much is discussed with you, but there are a lot more things in file handling that you have to learn. Okay, let's do this question. Lambda functions are discussed with you. Okay.
Yeah.
Okay, no issue. Let's do this first. So L is an empty list. Okay. Then for x in range 10, if x percent 2 is equal to 0, that is if x is even, then L dot append x, else L dot append odd. Okay, so which of the following codes are equivalent to this above code snippet? So basically, what is this above code snippet doing? In the L list, it will go from, if I say x in range 10, that means it goes from 0 to 9. Now for every even number in the 0 to 9, it will append that number, and for every odd number, it will append the word odd, right, in that sequence. So like for 0, it will have 0, for 1, it will have odd, then for 2, it will have 2, for 3, it will have odd, like this. So now you have to find out among these 4 lines of code that are given below, which ones are similar. Okay. So try which one is similar. L, first one, let's see, x, if x percent 2 is equal to 0, else odd for x in range 10. Is the first one correct? That means we are checking that for every x, we are checking if x percent 2 is equal to 0. That means if x is even, right? Then you add x, else you add odd for every x in range 10. Is
Yes.
this similar? Same.
Yes.
Second option, see. What is different here? The
Colon.
colons are missing. So will it work?
No.
No. Third one, odd if x percent 2 is not equal to 0.
Yes.
Else x for x in range 10. Same thing. Now instead of checking even, we are checking odd, right?
But
So odd will be printed every time the x is odd. That is x percent 2 is not equal to 0. Otherwise, you will put x in the list.
here also colon is not there.
Yes. So is this going to be correct? See. Let me just do this one. So we have, I think, done something wrong. This
B is the correct answer.
B is correct because we don't need the colons here because we are writing in list comprehension. In list comprehension, you don't require colons. You require it when you write it in this type of indentation code, right? line by line. When you're writing, you require the colons. In comprehension, if you write the entire code in one line inside of the list, do not require colon. So this one, B and C are correct.
Okay, ma'am.
Why D is not correct? Because it is saying L append X if X% is equal to odd, else odd for X in range 10. So L append X. This is not correct. Okay, you can just write X. If you're doing a list comprehension, you can directly write X if X% is equal to 0. So because of this, this is wrong. L dot append X. Now, last question we can discuss here is this number 20. This I will discuss if you have done lambda functions. So, confirm that. Is everyone already familiar with the idea what is lambda function?
I don't think so. It's in the syllabus.
Okay. Okay, then I will not do this because first you need the concept to understand, then I can do a problem on it. Fine. So 3 questions out of 20 we didn't do because you are not familiar with it. Rest of the questions, everything is clear for everyone, right?
Yeah.
Other 70. Okay, so this is the type of question you can expect in your exams also. Not even this hard because qualified exams are usually you get easier questions. This is a pretty standard level. All right, so I think you have one more DAD session this week. Do you have? You can check in your schedule if you have. So
Yeah.
that will be again one more revision. So I'll let the instructor know about that. Yeah, so that's it from my side. Thanks for joining, everyone.
Can you share this material?
I do not know if I can share it with you because if I have the PDF, I will try to share. Okay, I am doing it from the portal. If I get the PDF, I'll share with you.
Okay, ma'am. Ma'am, this was, I think, our last session.
Okay, this is the last session. Okay.
For qualifier, it's a last session, and previously Google Sheets are shared with us.
All right. So for qualifier, the syllabus is clear to you, right? What is the syllabus given to you? If anyone has the syllabus, can you just share it here? Like, is it given to you that how many weeks of content are going to be there in qualifier, or do you just have like what topics are there? So any whatever topics we covered, those are part of your syllabus, right? 8 week syllabus. Okay. So first 8 weeks, yeah, fine. That's why I think file handling is there in the syllabus because 8th week is for file handling. Okay, someone has shared. Let me check once quickly because I don't usually take these classes. Okay. So syllabus is introduction to Python, variable, string, basic, conditional statements, loops, lists, collection, recursion, file handling. Okay, yeah, your object oriented part is not in your syllabus, so it's fine. But lambda function is there. Okay. So don't skip that. That lambda function is present in the syllabus. It is in the one of the initial weeks only. Okay, rest of the things I think we have discussed, so it's fine. Recursion is very important. Please be comfortable with that type of question. The ones we did, like f of 10,000, f of -8, how to go to the last traceback call. Okay, so be comfortable with that type of questions, and also don't skip lambda functions.
What is the high weightage of the topic like covered for the exams? Like,
Weightage. Let
yeah,
me.
which
Okay.
topic will be the high weightage?
See this, all of these collections, right? List, tuple, set, dictionary. This questions based on these will have a lot of weightage. Again, recursion. At least 1 to 2 questions are going to be there from there. File handling, I don't think will have a lot of weightage, but initial weeks are very important, like conditional loops. Collections will have the highest. I think the weightage will be highest in collections because there are different questions that can come from list, tuple,
Okay.
dictionary sets, all of them. Okay, so function collection, this part, all the weeks are important. Collection is most important. Okay, yeah.
Okay,
All the
thanks.
best, everyone. Thank you.
Thank you.
Thank you.
Thank you.
Thank you, ma'am.